Problem number 5 is a non-calculator problem. Let R be the region enclosed by the graphs of g of x and h of x, the y-axis, and the vertical line x equals 2 as shown in the figure above, and it asks us to find the area of R. Before I even do that, I'm going to try to figure out which one is g of x and which one is h of x. The cosine graph looks more like this bottom one down here, so this one is going to be g of x, and this one, 6 minus 2x minus 1 squared, is a upside down parabola, which is definitely that one. Okay, so finding the area, we need to know our limits. We're going to go from an x value of 0 to an x value of 2. And then to get the area, we're going to do top minus bottom. So top minus bottom, which means we're going to have h of x minus g of x. Okay, now I'm just going to, we don't get to use your calculator, so now I get to fill things in here. So h of x is 6 minus 2, x minus 1 squared. I guess I don't need it there. Minus g of x, which is going to be negative 2 plus 3 cosine pi over 2 x dx. I think I need one more parenthesis there. Okie doke. So before I even get started with this, I think I am going to break it up into several different, actually 4 different integrals. So I'm going to be taking the integral from 0 to 2 of 6 minus the integral from 0 to 2 of 2 x minus 1 squared. This minus is going to be distributing, so this will actually be plus the integral of 2 and then minus the integral of 3 cosine pi over 2x. And all of those would, of course, be dx if we wanted to put those in there. Not really necessary. Okay, so the antiderivative of 6 is just 6x. And then I'm actually going to, when I finish this, since they're all from 0 to 2, I'm going to be ignoring the limits of 0 to 2 until I'm all the way done. Okay, so this next part, I noticed that I have something in parentheses, so I'm actually going to be doing a u substitution, which would be u equals x minus 1. du would be just 1. So notice I actually have a 2 on the inside, so I'm going to be multiplying by 1/2 on the inside, so I'll multiply by a 2 on the outside. So that new thing is going to be minus 2, the integral of u squared. So I'm going to be writing stuff up here, I think, because I'm going to totally run out of room. Okay, so I'm going to have 6x, and then the antiderivative of u squared will be 1/3 u cubed, so it's going to be minus 2/3 u cubed. And so if I plug that back in, I'm going to have minus 2/3 x minus 1 cubed. So that's the second part. My third part, the antiderivative of 2 is just going to be 2x, so it's going to be plus 2x. And then my last one, once again, I do see parentheses, so I'm going to do u substitution. I have u equals pi over 2x. du is equal to pi over 2 dx. So I'm missing the pi over 2, but I actually have a 3. So I'm going to be multiplying the inside by, let's see, 2 over 3 pi. Yes, hold it. Oh, wait. I need pi over 2, sorry. I'm going to do over pi over 6, actually, because pi over 6 times 3 is pi over 2. So I'm going to be multiplying by 6 over pi on the outside. Okay, so now I have, if you can read that jumbled mess, minus 6 over pi, the integral of cosine u. And then the integral of cosine u is sine u. So this will be negative 6 over pi sine u. So up here I'm going to have negative 6 over pi sine of my u, which was pi over 2x. And then I'm ready to evaluate it at 0 and 2. Okay, so all right, we are ready. So now from here, I'm just going to get to plug stuff in. So if I plug in 2 here, I get 12 minus, if I plug in 2 minus 1 is 1 cubed times 2 is 2/3, so it's going to be 12 minus 2/3 plus 2 times 2 is 4 minus 6 over pi sine of pi over 2 times 2 will just be pi. So that's the first part. And then if I plug in 0, we're not going to assume that we're going to get 0 as an answer. So we'll keep going. 6 times 0 would be 0 minus, if I plug 0 in there, negative 1/3, negative 1 to the third is negative 1 times negative 2/3 is going to be plus 2/3. and then plus 0, and then minus 6 over pi sine pi over 2 times 0 is 0. Okay, we could leave our answer messy like that and receive full credit. I am going to work this farther. I would end up getting 16 minus 2/3. This would turn into 0. And then I get minus. This would also turn into 0, so I just get minus 2/3. And if I work that out, I will get 44/3. Okay, points for this problem. There are 4 of them. Okay, I would get a point for properly setting up this integral right here. Okay, I could write it like this. I would get full points if I wrote it like this too, because h of x and g of x are defined. So that's 1 point. Okay, I would get 1 point for the antiderivative of this first part. So this would be worth 1 point. And then this last one is also worth 1 point. So 1 point if you get all 3 of those parts, 1 point if you get this part. You could have combined those into 8x, so just however you did it. And then 1 point for the correct answer. And again, you would have gotten a point had you just left it right there. Just be careful. Only go farther if you're super confident, because you might lose a point if you evaluate it incorrectly. So that was worth 4 points. Okay, part B says region R is the base of a solid. For the solid, at each x, the cross-section perpendicular to the x-axis has area 1 over x plus 3. Find the volume of the solid. Please notice they very nicely gave you the area. Wasn't that kind of them? Okay, so we know for volume of cross-sections, we're perpendicular to the x-axis, so our cross-sections will go this way. So we're going to have everything in terms of x values. So if I have, I'm going from an x value to an x value. So once again, it's going to go from 0 to 2. And then basically it's just, remember, we just put the area right here. They told me the area. So it's just going to go from 0 to 2 of 1 over x plus 3 dx. And now we get to evaluate this by hand. Since I do see something in the denominator, I'm going to do a u substitution. We'll let u equal x plus 3. Du will equal 1 dx, which I totally have. So this problem turns into a du over u problem. And hopefully you remember that the antiderivative of du over u is ln. So ln u, which is x plus 3. And then we just get to evaluate it at 0 and 2. So if I plug in 2, I'm going to get ln 5 minus, if I plug in 0, I get 3. And that is my answer. That was worth 2 points. If I properly set this up right here, I would be getting a point. And then if I got this answer right here, I would also be getting that second point. So this part was just worth 2 points. All right, C, write but do not evaluate. That's always so nice when they let you do that. An integral expression that gives the volume of the solid generated when R is rotated about the horizontal line y equals 6. So y equals 6 is up here. And I can see when we do this, when we revolve it, first of all, we are on a horizontal axis, so it's either going to be disk or washer, and it is going to leave a little bit of a gap. So we are definitely going to be using washer for this setup. So we're going to have volume equals pi. Once again, it's going to go from an x value to an x value, so still from 0 to 2. And then we are going to do the, remember when I'm revolving it about way up here, we're going to do the curve that forms the outside of the shape, the one that's furthest away, which is actually going to be the g of x. So we're going to have g of x. Remember, if I'm about the line y equals 6, though, I need to move my equation down 6. And it's outer radius squared minus the inner radius squared, which would be the h of x. And we also have to move that down 6. So then that would be my correct integral. If you wanted to go a step farther, you could actually write in the equations g of x and h of x. That is not necessarily necessary. Because g of x and h of x have been defined. So we should be good. So that one is just done. It was actually worth 3 points. If we had the correct form here where we're trying to do outer radius squared minus inner radius squared, we would get a point. If you actually had the correct things in there, so maybe if you forgot your 6, subtracting 6, you would lose a point for the next part. But if you have that same setup, you're going to get a point. And then you get a point for having the correct pi on the outside, and it's going from 0 to 2. So plus 1 for having that set up, and then plus 1 for actually having that. So this was worth plus 3. So altogether plus 9.